All right, so before we get started with the textbook, and you can already, if you want to go ahead and go to our project while I'm talking. Just go to Module 4. You write the Module 4 overview, and again, the Tuesday and Thursday lecture over here. On Tuesday, we'll be looking on creating random passwords, or that is what we're going to be going over today. But I just want to take a moment to talk about Lab 4 and 5, which was the one that is associated with this and next week. It is a bigger document than normal, and that's part of the reason why I'm bringing it up. So one of the keys over here is that you'll be learning how to write functions. We're going to be learning how to do these things as functions. If you don't know how to do that yet, don't worry about it. You can write the code first and we can figure out how to put in a function later. But the format for what you're going to be doing is as follows. You create a function, which is essentially a verb in the programming language, and there's associated textbook things with that. And then we do the input outside here. We ask the user about how many times they want to run something or what parameter they want to set outside of the function. I generally do this last because what you can do is you can just simply type in you can just put in what you want over here and run it, and it will print it out. Test out with this code, and you should be able to see how that works. And the TAs will help you. I'll help you with that. But if you come to me without functions, I will just simply penalize you until you fix it. Right? It won't be a permanent penalty. I'll just tell you to go back and then give you your points back when it is fixed. Make sense? Right? Because it's easy to miss that. Also, I give hints on how to use the hello world in different ways, using the sep and the end arguments, which are pretty nifty. They're pretty nifty tools. But we have a couple of, so let's take a look at what our problems are. Okay, our problems are, the first one is the 99 bottles of beer problem. This is a classic one, which is basically printing out the lyrics of the 99 bottles of beer on the wall song. Which I've never actually heard people sing it, but the idea here is we've got it's a counting down song, right? Start with 10, then you go to 9, then 8, then 7, and then at the end you'll have 1 bottles of beer on the wall. And notice that I don't care is that I don't have any kind of that it's bottles. It's 1 bottles still. That's so you don't have to worry about singularizing or pluralizing anything, right? It's all going to be bottles, right? Don't worry about that. That's the main thing. So keep in mind that we just need to use a variable because what's going on? One thing is varying, and that's the current count. And we can subtract 1 from that current count to figure out what the next count's going to be. The next one is to make a multiplication table. Right, give it a parameter and it will print out a multiplication table, right? So here's 1 times 1, 1 times 2, 1 times 3, 1 times 2, 2 times 2, 2 times 1, 2 times 2, 2 times 3, 2 times 4, 3 times 1, and so on and so forth. So it's just basically doing multiplication together. This one essentially requires us to use a nested for loop, and that's the reason we have this one in there. Summation of squares. I just need this number to be calculated. I don't need this to be printed out. Although, if you do that, again, that's not wrong. And then the next part is the big reason why we're going to be doing these as functions. What we're going to be doing is we're going to be doing turtles to draw things. The first thing is drawing a square, getting your turtle to draw a square. We kind of already know how to do that. The next thing is to get your turtle to draw a row of squares. Now, typically I like my turtle to be back here after it's done drawing, but that's up to you. But drawing a row of squares. Now the key here is that you can, since a row of squares is made up of squares, you already wrote a command that tells you how to draw a square. So what you will do is you'll essentially hook draw row into draw square. Otherwise, you're going to need for loops nested in for loops, which we try to avoid at least having to read that. Similarly, drawing a grid calls drawing a row, right? A grid is just simply a lot of rows. Make sense? And then stairs is our final part of the assignment. So both grid and stairs work by using the draw row uses draw square. So these parts rely on the previous parts. And it makes it a lot easier if you don't have to start from scratch. Then two more. Drawing a n-sided polygon, which we've kind of worked on. We worked on that last week. And then what I called super spiral, these are fun things that you can, and this is the fun thing you can do with turtles. And this looks like it's hideously hard to do. These are my arguments. Draw n-gon spiral, Bob 6, 135, creates a spiral of 35 hexagons. Each hexagon is offset by 20.57 degrees. How did I get that? 720 divided by 35 is equal to 20. Your output does not need to match my output. So what in the world is going on here? How am I even actually getting anything? Right, is probably what you're wondering about. So this is a hexagon. So let's see. No, I don't want it to be that thin. Jeez, there's that thick. So we can kind of view one. And all this is a bunch of hexagons. He just has a different starting point for each hexagon. This is essentially a much more chaotic version it's not even more chaotic. It's just simply a more complex looking version of the turtle clock, but it's the same principle as the turtle clock. It just does one and then it adjusts a bit. There's also some extra credit assignments in this one. Printing out this hourglass figure using for loops, slash figure using the for loop, and then improving the super spiral to be the super duper spiral, as I put it, which is to make some color with it. Now, before you completely panic, notice that this says Lab 4 and 5. The due date is all the way in October, right? So this one is meant to be worked on for a while. I've seen people do it this week. I've seen a lot of people take 2 weeks to do it. It's meant to basically take some time to space out as you get adjusted to this material. But I just wanted to mention that, and it is worth almost as many points as two assignments, right? It's 180 points as opposed to 200. Sorry, it's 180 points as opposed to 100. So not quite 2 assignments worth, because it's almost, but not quite 2 assignments worth of material. All right, so to get to today's exercise, wow, apparently what is going on with the microphone? Let's go ahead and see. Properties. Oh, I haven't adjusted this. I haven't needed to adjust this. Okay. So let's go over here to, again, I scroll down to the Module 4, Turtle Sequences and Loops. Today we're going to learn about sequences by doing Tuesday's and Thursday's lecture. So on Tuesday, we'll be looking at creating random passwords. Okay, and that's this exercise over here. Python sequence, and let's just go into the Control F sequence. Come on. Do you have a definition? Do you have an official definition for what a sequence is, Python? Right, tuples. Right. Sequence types. List tuple M range. Basically, so I'll come back to this in a second. I just wanted to have that pulled up for us as an official definition. But what are we doing today? we're going to be generating a XKCD style password. So this is about basically our typical password policies. Now, Temple actually has an amazingly good password policy, which is that the longer your password is, the less complex it has to be. And this is part of the reason why, okay? So so typically the way you generate a password, right, is you take some uncommon word that's in the dictionary, right, like troubadour as it puts over here. You capitalize some words, you add some substitutions in, right, like a 0 instead of an O, a 4 instead of an A. Then you tack on a random symbol and a number at the end, okay? You can add a few more things to just kind of to try to make it more complex as needed. But typically what this ends up being is he calculates this as what is called 28 bits of entropy, which is basically uncertainty in this case. That's a whole kind of Wikipedia article on its own, which is entropy. Entropy, we look at this, not the scientific concept that measures disorder or uncertainty in systems. So, where's Claude? Shan? Yeah, Boltzmann. Let's see. I was looking for that. Yeah, a lot of it does a lot to do with thermodynamics and stuff like that. But where is that? Information theory, Shannon entropy, right? The average level of uncertainty in an information, how certain we are that it would be the correct password, right? That is kind of what we're asking there. Okay. And the calculation that he's able, and that why that's more important is that he's using this to he used that to create a calculation and said, hey, if I can do 1,000 guesses a second, then this many things takes about 3 days to crack. Right? And then he talks about cracking a stolen hash, which is an entirely different thing for passwords. But you'll learn about that later, or I'll talk about that later. But suffice to say, passwords are almost never stored on the server anymore. Instead, what's basically is stored is a unique receipt of your password, and whenever you enter your password, you actually generate that unique receipt, and it's checked against that unique receipt. And you can't go from the receipt back to your original password. That's what a hash is. All right, anyway, point being is that you create this, and it's easy for a computer to guess, hard for you to remember, because are you going to remember, if I were to put this away, could you remember all these things, right? Where the 0 is, where the 4 is, what the symbols are, right? On the other hand, if we simply take 4 words from the dictionary, correct horse battery staple, right? 4 random words, doesn't even matter if they're common or uncommon, that's a lot more uncertainty for a computer to deal with. 44 bits, which he calculates at the same rate would take about 44 years to guess. And it's hard for a computer to guess, but very easy for us to remember, because for a computer, it's a lot of individual symbols it has to crack. For us, it's 4 words. 4 words are very easy for us to remember because, again, that's in the range of stuff we can easily remember. Correct horse battery staple, right? And the punchline he puts is 20 years of effort. We've successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. It doesn't help that so many of us use 1234 or password as our password. Those are actually exceedingly common passwords. Anyway, so Temple, as I said, has does it pretty well, and so every semester or every time I have to reset my password, I just end up choosing 4 words based off of what's going on around me, and that is my new password. And now I have a nice secure password that I don't have to remember. That's a lot easier for me to remember. Oh, and yeah, you can throw spaces in there too, because why not? So the idea here is that we are going to create randomized passwords. We're going to start out by creating a tool that will just simply create traditional random passwords for us, right? And that's what we're going to work with today, okay? What we're going to be doing is we are going to be working with two types of sequences. We're going to be working with one that we've already worked with, which is strings. It's a sequence of symbols. And we're also going to be working with lists, which is a sequence of items. Now, you may not have worked with lists before, but you want to know something? That's okay. Because they are both sequences, the operations we are going to do on them will look identical. Meaning that all you have to care about is the variable name, and the algorithm will work just fine. So make an 8-letter password by combining characters from the 3 strings. Now, to do this, if we want to make an 8-letter password at random, take a hot guess at to what library we're going to need to use today. Anyone? Import random, exactly. We're going to need to use the random library. Now, the random library in Python is amazingly good, mainly because of just some really useful functions in it. Normally, you'd have to do things like generate a correct index based off the range of this, and you'd have to calculate the length of this. No. Python does an amazing job. Print. So once you've imported random, you can do something like this. Random dot choice. It's probably one of my favorite functions made in Python because it makes my job so easy. You give it a sequence, like letters, and it will choose an item from the sequence at random. So here it chose K, I, L, S, I, D, D, R, U, right? It just simply chooses this stuff at random. And again, what I'm going to do is if I do a for loop in range 10, right, it'll print out a bunch of random letters. Now, why is it printing out random letters? Because I told it to print out from letters. If I wanted to print out numbers, it would come from numbers, like this. And if I wanted it to be from capitals, it would be that. So there's a couple of different keys that you're to build this from. All the tools are going to be here, but there's a couple of key insights you got to figure out in order to do this. Now, mind you, I don't want to also read this thing vertically. I want to have a single password that I can read left to right. So what we're going to have to use is, you're going to hear this again and again, is something called an accumulator, right? We've seen that when we're doing a running sum, when we have to add, and we've seen an accumulator when we did this. Total is equal to 0. This is not part of the program. Don't bother writing this down. Total is equal to 0 for I in range 0 to 100, right? Total is equal to total plus I. Print total. And that will print the total of the sum of all the numbers from 0 up to, but not including 100. So it adds 0, then 1, then 2, then 3, then 4, and it adds up all the numbers from 0 all the way up to, but not including 100, and we get 4950. That's a running sum. We call this an accumulator because total accumulates some value, right? And it makes sense because we're going to be adding things to it. It's a running. We specifically call this a running sum, but the reason we use this more generic term, accumulator, is because we can do this for things other than numbers, right? That's kind of a big insight in computer science that makes it its own thing rather than mathematics. You can do it for things other than numbers. So how would that look? It would look like this. So all accumulators essentially start with the identity of its domain. In other words, we start with 0 when we're adding because anything plus 0 is the thing you added, right? That's the identity. In multiplication, that would be 1. 5 times 1 is 5. When you throw something into the when you combine something with the identity, you get the thing back. So for a string, that's this, which you may not have seen before, which is just simply 2 quotation marks. This is what we call an empty string. It's a string of length 0. It has nothing in it. Make sense? Make sense so far? So what we want to do this is do similar to what we were doing over here, which is that instead of doing a running sum and adding a number, what we're going to do is we're going to add a random string to this, a random thing from numbers, or a random thing from caps or letters. Now, how do I make sure that I actually get all 3? My suggestion is you combine all these 3 into a single variable. And that doesn't need to be a lot of work. You just simply say, like, letters plus caps plus numbers. So go ahead and try that for like 5 minutes. I'm going to go ahead and pause. All right, so we're going to start from, again, that easier solution that I was talking about. Rather than just trying to generate a combination password, right? I've got numbers pulled up, so I might as well use numbers, right? So I'll use random.choice. So we need to generate an 8-letter password. We're going to generate an 8-number password instead. And the way this works is fairly straightforward. What we're going to do is we start with an empty password, and just like we were doing this over here, we're going to do password is equal to password plus our random choice. Make sense, everybody? Right, so as above, so below. Right? We're just going to make that password, and then at the end, just like we printed out the total sum, we're going to print out the password. Okay, like I said, I'm just going to start this from an easier version, which is just 8 random numbers. And, oh, come on. There we go. Sorry, let me adjust this. I don't know why it decided to just go crazy there. But we have this, and we get 8 random numbers. If I run this again, I get a different set of random numbers. Right? Easier to view them as individual random numbers, and I can emphasize that by just being lazy and adding a space in between them. So password plus a random number, what we already have, plus a random number, plus a space. And now you'll see that they're separated by spaces, which emphasizes that they are not one number, right? But instead a bunch of random ones. If I remove that, well, let's go ahead and remove this. Now, so we've already got kind of the makings of what we need for a password over here. Now, instead, what we need to do is we should do, well, we wanted letters and capitalizations, right? Here's it is with letters. But we want basically to choose from it. We want the computer to choose something at random from all of these common possible things. So how do we do that? Well, you have to choose at random from a sequence. So we can make a new sequence. And sequences are extremely easy to make from other sequences. You just add them together as we've been seeing, right? You make a new sequence. Here, you're actually making a new sequence by adding what was in the old one. So let's go ahead and say, let's go ahead and call this possible, we'll call this characters because it's all possible characters, right? And we'll add letters plus caps, plus caps plus numbers, right? And then what we'll do is we will tell it to, we'll go ahead and print this out. We'll print out characters just so you can see what it is, right? If I print out characters, you see that it is A through Z, and 1 through 9, right? Just like we had. So now if I switch from letters to characters and hit run, I now get randomized passwords. Let's go ahead and comment it out. we go. Again, the issue is I have to be zoomed in so the people back in the back can see. Okay. But even easier is if you can see it on your own screen. So I'm going to go ahead and share the code. So you'll be able to reload that and see it. Now, Python says that basically we have, there are three basic sequence types: lists, tuples, and range objects. We are learning about lists. We've kind of dealt with range. Range kind of is weird. It generates a sequence on the fly. You just got to just keep in your mind, range is the sequence of numbers, right? From 0 up to, but not including this number. Lists are stuff we're learning right now. And strings, it says it has its own special section because they're awesome. They're a sequence of text. And there's all these kind of things you can do with sequences. You can concatenate them. You can check things are in them or not, right? But it's this kind of addition that we care about, right? Which is that you can add strings together, right? You can add a sequence together. Okay? On the flip side, for this next part, we want to make a better password, right? One of these passwords that are created from generating 4 random words together, right? Okay? Okay? Now, I just want to point out the same thing holds, right? This is a list. A list is basically, rather than starting with a quotation mark, starts with the bracket, which is the character on an English keyboard, right? Those are the characters right above the quotation mark characters, right? Left bracket, right bracket. And they're made up of items, okay? So the items in this case just happen to be strings, but those items could be anything, including other lists, as we'll get into. That's a bit complicated, but you've made lists of lists before when you've done outlines, right? In fact, you've made a list of lists in your own life I'm sure when you've done to-do lists and broken an item down into multiple parts. A list, not to put too fine a point on it, is exactly what it sounds like. It is one thing that has a collection of things in it, right? And that collection of things can either be, it has an order, and that order can either be important or not important, right? A to-do list might be a step-by-step thing, whereas a grocery list, that's generally unordered, but they're both lists, okay? And we'll learn more about how to use these, but the important thing is that because they're sequence, random works the exact same way, which is to say, if I import random and I print, random dot choice, and then I do nouns, right? I'll get puzzle, shape, resistance, view, constitution. Now I'm getting a random whole word as opposed to a random letter. Why is that? Well, sequences have items in them. In this case, each item is an individual letter. You can think of it this way. Each item is an individual letter in this. But in this list over here, as opposed to a string, each item is a string. Each item in this list is a string. So if I'm choosing something at random from this list, I'm going to get a random word, specifically a random noun. Furthermore, they can be added together in the same way. Verbs plus nouns. If I can just hit the plus key for once. If I add those things together, I'm going to take represent, warm, and then over here we start getting nouns again. Pull, puzzle, merit, traveler, quality, right? So it combined those two. And didn't just like shuffle them together. It said, here's the first one, and then I'm going to tack onto the end the other one and combine them into one megalist. Okay? Just like how you can glue two strings together with concatenation. Same idea here. So given that, you should have, and given more importantly what we had previously, you should have all the tools you need right now to make a password generator that generates a password from 4 random words, right? Right? All you have to remember for blank in range to do it to do it the specified number of times. I'll get this into about 250. So I think I went maybe a little fast. Let's go ahead and just review what I did up here for this password one, okay? So I imported random, which is a library that gives us the ability to make random choices. Technically, they are what we call pseudo-random choices because it's an entire philosophical discussion as to whether or not randomness is actually a thing. Like, right, if we flip a coin, we say that's random, but if you somehow knew the amount of forces that were going to be exerted on it, the air pressure, the air resistance, all that stuff, you could technically do a mathematical calculation to figure out where it ended. Technically, right? You can't actually, but like, that begs the question, is that actually random, right? We completely sidestep this discussion and just simply say it's mathematically random for all purposes of statistics and counting that it is going to be random. Okay. Now we have three strings here, letters, caps, and numbers, right? Strings are just these big globs of text, as we've been messing with. What I've done is I've just combined them over here into one big string. Essentially, I put them all into the same pile. Because if I'm going to be doing things at random, I want to be able to just do one random operation per character, per glyph, to grab it out. Similarly, for the second password, I want to just do one random operation at once because I want it to look really random. I want there to be a random number of numbers and letters and capital letters. I want that to be stuff. So each one of these individually has an equal chance of being chosen. Okay, and that's what random.choice will do. It says, given this pile of things, or the sequence of things, I'm going to choose one there at random. Everything, each individual item has the same exact chance of anything else. Password over here, right, again, is equal to empty string. And again, I want to just emphasize, there's not a space here. A space here would be some data. What we're looking at, this has a length of 1. It's technically a letter, even though it does not look like a letter, right? This has no letters in between it. It's a bit hard to distinguish, but if you were to put it on a test, I'll know when you mean that versus a space. It's not something to stress about there. It's super easy to understand, but sorry, this is essentially just 0, just the string equivalent of 0, okay? So here, we next do our for loop, for blank in range. For loops always use the same format, right? For, and then the second part is a variable. If we don't care about a variable, if we don't care about something changing and having control over how we change it, we just leave it through as a blank. In is the next part, and then range, which basically says we're generating a range of numbers, which our variable will be. But we're not actually using a variable, so this format just simply means repeat the following 8 times. Right? For blank in x means do it x times. So for blank in range x means do it x times. So here we're doing it 8 times. We're taking what we currently have as a password, adding the randomly chosen character, and storing it in password. And then we take what so let's say we randomly choose A, we'll have A in password. Then let's say we randomly choose 1, then we'll have A1. Then we'll randomly choose 7, we'll do A1 plus 7 make it A17, and then it will get stored in password. We do that 8 times, and we print out the final result. So that's how we're ending up with a random password. Now, similarly for this one, right, we have our 3 parts of speech, our adjectives, nouns, and verbs, our collection of adjectives and nouns and verbs, right? And we're using I assume we're using a subset of this to avoid what we call the Scunthorpe problem, which is this fun little problem basically that we don't want to have any curse words in there because then people might get upset. So we're just going to use this chosen set of random words: nouns, verbs, adjectives, right? So here, if we choose and just like we would choose a random letter, we can simply choose a random word. So let's go ahead and say, rather than calling it characters, I'm going to call this words, right? And I'm just going to say nouns plus verbs plus adjectives is all the words we have access to. And so if I do this, random.choice words, we'll start seeing, one second, we see language. Sorry, I'm just trying to scroll up. Language, view, funeral, modify, statement, dot, improved, engine, processor, cruel. So we're seeing verbs, we're seeing adjectives, we're seeing nouns. Although it's a fun part of the English language that we don't necessarily know that some words are nouns or verbs, right? Right? Wish could be a noun or a verb depending on the context. Okay. So now we need to put 4 of them together into a password, right? So we need to make 4 random choices. So 4 blank in range 4 to do this following 4 times. 4 blank in range 4. Complain free mass offer. Complain about a free mass offer. Hey, that's an easy to remember password sequence. So now let's go ahead and put them together into an actual variable so we can read it all out at once. Password is equal to empty string. Same deal here because we're combining text. Busy, conclude, question, profession. Okay? So now that came, even though we added a new variable, it didn't do anything new because I didn't tell it to do anything new. So now what we'll do is rather than printing this out, oh my. Give me 1 second. I am going to just run this, which will error, but I'm going to reload it so that those boxes reset. Okay. Password. 4 blank in range 4. Password is equal to password plus random.choice words. And then we'll print out password. Okay. Got to actually remember to print it out in order to print it out. And then I'll go over some common mistakes. Oh, unmatched braces. Why did I do that? Oh, I just held it down for too long, or forgot to delete the old print one. Present, share, interesting, municipal. Right? So we've got 4 words, although it's a bit hard to see what our words are because, they're not separated out. Now, a common mistake that you might do is you forget to do this, and you might just do password is equal to random.choice, and it'll just simply display the last randomly chosen one, right? It'll have been 3 other words before. And this sometimes happens because this does have a shortcut. There is this shortcut we can use in addition and concatenation and that kind of stuff. This kind of self-modification can be written as plus equals, which I believe your textbook goes over, but I like to write it out at least at first. We'll see that more later on, especially when we work more with numbers. But let's talk about this. Engine weaken, isolation essential. So let's make it a bit easier to read. Okay? And because it's easier to read, it'll be easier for me to remember it, right? So I'll put in a space. And we're going to have some fun now. Necessary, steady, speed, persist. And I go, great, that's my password. So let's say I use this to generate my password for Temple's account, right? I copy this, copy it, paste it in, and then, re-enter your password. I paste it in again, and it goes, you've changed your password. And now I go to enter my password on the Temple University website, and I type my password in, and it tells me my password's wrong. How could that possibly be? I've memorized the 4 words, and I put spaces in between them. And the answer is that we have just been betrayed by one of the most common issues with for loops, what we call the fence posting problem. Because our password wasn't 4 words separated by spaces. It was 4 words each followed by a space. Subtle difference, right? Space here, and space here. But also a space here. That's the fence posting problem. Named such because you need, if you have 3 pieces of fence, you need 4 fence posts, right? The idea here is that you need a different amount of connecting material versus posts. Here we've got 4 words and we need 3 spaces between them. And how you deal with this depends on different things you can do as programmers, okay? There's a couple different ways I know off the top of my head to deal with it. The two that I know being slices, but we haven't really tackled slices yet. But simply put, what I would do for that one is just simply say, that's one thing, and we haven't learned that yet, but we will. And now that space is gone, right? This is just simply a shorthand for saying everything but the last character. I know, it looks very technical. I assure you it's not. But another way to do that is just simply by manipulating the loop and doing an extra line of code, which is to say, we'll do this 3 times because we need 3 of these. 1, 2, 3. We do 3 identical actions, and we will do 1 action that does not have the space added. And that's another way to solve that fence posting problem. It's a very common problem that comes up. And if you separate by spaces, that totally may have happened. And that's totally a thing that happens and catches people off guard, even the most experienced. It's especially when it's like this and you're working with invisible characters, so to speak, the characters you can't see. Right? Those can be a real pain. Okay. This part's boring. Just simply hit run on it. That's not what we need. These are just simply different methods you can do there's methods you can use to replace stuff. It's boring though. I don't want to bother with it. Okay. Next part is one I'll just do in front of you, which is again, we're just learning how to use this random dot choice. We're learning how to do this stuff. And this is that challenging part that I like to get to, which is how easy is it to crack passwords, right? Actually. Right? So we're going to use a 4-letter password as an example because that's doable in a class period with testing, right? Although we do need to make some changes over here. So let's take a look at the code we've been given. So it's a lot of code, but I promise it's not terrible. Okay. Okay. So the first thing is import random, which we know about. Import sys, which is not one we really need to know about. Import sys is interesting. Sys is short for system, right? Sys is short for system, and basically all it's doing over here is this single line, which is sys.set execution limit 60,000. That's 60,000 milliseconds, so 60 seconds. What is that doing? Well, remember how I mentioned a couple times last week that if you accidentally write a loop that runs forever, what will happen? It will crash out after 30 seconds, right? It'll automatically crash after 30 seconds. This just changes that limit to 60 seconds. Okay? Next, we're going to set the quote-unquote hidden password of the user to ABCD, just simply to show how easy it is to kind of guess these passwords, random passwords. Okay? number. We're going to count how many guesses it takes us to guess this password, okay, or the computer. And now we learn about, and now this, again, this is why it's a challenge. You haven't been introduced to this material before. Well, we're going to do done is equal to false, okay? I mentioned this all the way back at the beginning of that there are that there's a few different data types. And then there's one called a Boolean that's true false, and we haven't had to use it before. That's used in if statements and while statements. It's used to simply say is something true or something false. And now we've got the while loop. There are two different types of loops in programming languages. The one that will be the focus of our first exam is for loops. And those are what we call definite loops, meaning they have a definite amount of time they run. There are also indefinite loops, and you can actually write a for loop that is an indefinite loop and a while loop that is a definite loop. But for loops are easier to write as definite loops is the point. It's easier to say a for loop runs a definite number of times. Like we've seen that with the range statement. It definitely runs this time. While not done. So not just flips around a truth or false variable. So this simply says while true. And until this true goes to done, when done becomes true, it will be while not true, which is false, and so it will end. It works grammatically the exact way you would think. It runs until we say done is true. Guess password, your code here. If your guess password is equal to my guess password, so this is an if statement to check if our two passwords are equal, print out how long it took you to find it, and set done is equal to true. So over here, what I'm going to do is add the code we need to guess the password. So first things I'm going to do, because we know this is letters, rather than typing out all the letters, I'm going to go be lazy and go all the way to the top and steal this, right? Letters is equal to A, B, C, D, and scroll all the way down. And then just simply put that there. Of course, in the amount of time that it took me to do this, I could have just simply done the following, which is just simply run my finger across the keyboard. And yeah, because the letters don't have to ever be in order if I'm talking about them being random, right? There are multiple valid approaches to doing everything. It's kind of funny, okay? But there's our letters, right? And what we need to do is we need to choose 4 letters at random in order to try to simulate how to randomly guess passwords. So that's what we'll do. We'll say, this is our guess password. So rather than using password, we're going to use guess password. We're going to say for blank in range 4. And we're going to say guessed password is equal to guessed password plus random.choice letter. Is it letter or letters? Let's double check. Letters. So we've got 4 letters here. Guess password is equal to this. Then for blank in range. And we just simply add that randomly guessed letter to the guess password. And then once we've created a password, what I'll do is that we have this guess num variable. And I'll just simply say guess num is equal to guess num plus 1. Again, as I mentioned, we can rewrite this. And so I'll rewrite this here to make it a bit easy, because this is actually an easier place to see this syntax. Plus equals 1. Plus equals is a shorthand for this statement where we're basically taking the variable and adding something to it. Here I'm saying increment this by 1. Make sense to everybody? It's the same as this. Wow, I'm hitting every key but the right one. Guess num is equal to guess underscore num plus 1. Okay. So if the guess password is equal to my password, found it after that many minutes. So let's go ahead and run, and we'll see how long it takes. It normally takes a while to find it, especially if I messed up, because then it won't work. What's important here is that at the beginning of every loop, while not done, we set before we start guessing another password, we change it to a blank password again. That's kind of important. Oh, there, it found it. So that took 187,363 tries for it to basically generate the random combination A, B, C, D, right? Run it again. Okay. And now, $140,000 tries. So I couldn't necessarily. It would be a while for me to do an 8-letter password. It would take a while. In fact, it would take 26. With what we're doing, it would take 26 to the 4th power times longer. What do I mean? Well, assuming that we go over each one once, there will be some repeats, but assuming we go over each possible combination once, right, we were just dealing with 26 letters, right? So we had 26 choices. We had 26 possible choices for the first letter, 26 possible choices for the second, 26 possible choices for the third, 26 possible choices for the fourth. What? I will. Yeah, I'll share this code. So overall, that meant that we got print 26 to the 4th power. It meant that there are 456,000 combinations to go through, okay, that to check for a 4-letter password, right? For a 4-letter password using only undercase characters. We typically, when we're looking at passwords, we're generating passwords that are 26 to the that are 8 characters long. So this is going from hundreds of thousands to there's 100,000, from millions to from bit to billion, 208 billion. Okay. And again, I'm just using a ruddy laptop and I'm working through a web interface, so I'm not going as fast as a computer could go. But it's not unreasonable to think, oh, a computer could do it, a million a second, a million in a minute, so 100,000 minutes for this, and it's also parallelizable, so you could have multiple computers work if you had a specific password you needed to crack, and no defenses on retries. It's not unreasonable to think that. Now, typically, we're looking at not 26, but 52 maybe, which is 52 characters, right? That's 26 times 2, capital, so that's capitalized and lowercased. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 53 trillion, right? Which looks pretty impressive. But again, modern computers can really attack this. Also, it's not typically this, but like somewhere along the lines of like you've got the special characters. So let's assume there's 10 special characters that people will use. You can even be generous and say that there's 20 special characters, and we'll still deal with in the trillions, I think. Over there. Let's see. 1, 2, millions, billions, trillions. Yeah. So 722 trillion possible combinations. Now, on the flip side, what we don't really appreciate until you kind of understand, until you actually see it, is that making the exponent bigger, even if the base is smaller, it does a lot, right? Because what we're doing, assuming here, let's assume that we do that we are using 4-letter words, okay? We're using 4-letter words, all lowercase. That's 4-letter words, 16 characters. That is orders of magnitude bigger. Orders of magnitude bigger. That exponent does a lot of work because that's a lot more multiplications going on, right? A lot more multiplication. This hides a lot, going on here? That's 16 multiplications as opposed to 8. Right? If these two things were closer to 20 and 10, you'd kind of understand, because though that's 8 of these multiplied together versus 16, that's a lot more zeros. Right? And if you use even longer stuff, and it ends up being like 20 characters, it just gets absurd. These things are, so using longer passwords are better. I mean, especially if you end up using longer passwords in this configuration, and most people will assume that you're not using the lowercase characters. They're assuming that long passwords could be anything because of the modern stuff, so your modern requirements, so that gets really big too, really quickly. But again, so even just adding a single character makes things order of magnitude harder for a computer to crack. Okay. So long story short, for password policies, you want to use a lengthy password you can remember. For certain things that you don't care, that you really don't care about, yeah, it's okay to use a password manager and generate a secure password with that. That's fine. For the things that you do really care about, I know it's a pain, but enable two-factor authentication on everything that you really care about. That means that not just using a good password, but you have to rely on the fact that you need a secondary means of logging in, a cell phone or an email address. And generally it's better to have a cell phone, just because that enables that. It makes, nothing has prompted this semester yet, but basically, and not a year goes by that some student ends up, who's inactive on Discord, ends up clicking on something and basically giving away their Discord information, and then their account starts shilling bitcoins on our web server. So two-factor authentication helps with a lot of these things. All right, so that is today's lecture.